We are starting chapter 5 with calculating the areas under the curve. So first we're going to do kind of a gross calculating method of doing the area under the curve. We're going to get more fine-tuned as we go on through chapter 5. But first we're going to find the area under this curve by calculating the area of rectangles. All right, so we're going to consider the area under the curve from A to B partitioned into N partitions. So I have drawn a curve from A to B, but I've only partitioned it 4 times because I don't want to get too detailed here. But the more rectangles we have, okay, the higher the value of N, the more accurate our estimation is going to be of the area under the curve, right? So at A is going to be our x sub 0 partition, and then at B is going to be our x sub n partition. So I did 4 partitions, right? So x sub 4 is going to be the B value. If we did like 100 partitions in here, that would be x sub 100, right? So we're going to start with A, right? This is going to be our x sub 1 partition. This is our x sub 2 partition. This is our x sub 3 partition. And then B is our x sub n partition. All right? So first, let's go ahead and talk about what the width of our partitions are. Right? And the width is going to be dependent on how many times we divide this area. So we're going to take the total distance from A to B. So it's going to be B minus A, and we're going to divide it by N, right? So in this case, I would have just done B minus A divided by N, right? So I want you to see that x sub 0 is just A, right? Now x sub 1 is 1 partition away here, right? So we call this delta x, right? The width of our partitions, the change in x. So x sub 1, we're going to start at x sub 0, and we're going to add a partition to it, right? And that's going to give us our x sub 1. X sub 2, we're going to start at x sub 0, and we're going to add 2 partitions to it, right? X sub 3, we're going to start at x sub 0 and add 3 delta x's to it, right? And then x sub 4, we should get, it is x sub 0 plus 4 delta x, but that should equal B here in our case because we only did 4 partitions, all right? So what we're going to do is we're going to figure out some rectangles here. Now there's 3 different ways, okay, that we can do an estimate of this area here. We can use left-hand endpoints, we can use right-hand endpoints, or we could use midpoints, right? So first I'm going to talk about using left-hand endpoints. Right? So that means that the height of our rectangles is going to be the height of the left-hand side. So if you can envision a bunch of rectangles here, right? We have a left side and a right side. We have a left side and a right side, a left side and a right side, a left side and a right side. So we're kind of using the middle partitions for 2 different rectangles. But the width of these rectangles is always delta x, right? So in this particular case, if I wanted to find the area, okay, using 4 partitions, I just want to do the height times the width of all 4 of those rectangles, right? All 4. So the height, we're going to use left-hand endpoints. So if I want, I'm going to draw these triangles in purple here. Okay. So here is my rectangle, okay, that I'm going to use to estimate this. And on the left-hand side, it's touching the curve right here. So this would be f of x sub 0, right? Okay. The height of our rectangle is going to be the height of what it is on the left-hand side. So that first rectangle, if I use left-hand endpoints, is got some area that we're going to calculate that is more than what's underneath the curve, right? So this is going to be kind of an overestimate, if you will. But the height of our first rectangle is going to be the function value at x sub 0 times delta x, right? The height times the width, right? Sorry for my mixing my pluses and my deltas there. All right, the second rectangle, if I use, the second rectangle is between x sub 1 and x sub 2, but if I use the height of what it's doing on the left-hand side, right, the left-hand side of the rectangle is the function value at x sub 1, right? So if I use that as the height, here's my second rectangle. And the area of this rectangle, the height is f of x sub 1, and the width is delta x, if you will, right? Plus, my third rectangle is the rectangle between x sub 2 and x sub 3. And I'm using the left-hand endpoint there, the left-hand side, to calculate the height. Right, so the height of the third rectangle is going to be f of x sub 2 times delta x, right? And then our last rectangle here is between x sub 3 and x sub 4, x sub 3 and b, and we're going to use the left-hand endpoint to calculate the height there. So we're going to get the function at x sub 3 times delta x, right? So when we calculate this area using left-hand endpoints, we're just getting height times width plus height times width, but the height is what the height at the left-hand side of this rectangle, right? So we can do right-hand endpoints. And so if I wanted to calculate the area using right-hand endpoints, again, we are, just for the sake of demonstrating, okay, we split A to B into 4 rectangles. So we're going to do height times width of 4 different rectangles. But we're going to calculate the height based on the right-hand endpoint, right? So I'm going to use green here, right? So the first rectangle here is the height is not going to be what it's doing on the left, but what it's doing on the right. So the height is going to be on the right-hand side and down, right? So the first rectangle is not calculating all the area, right? It's kind of an underestimate there. But the height is going to be what is the function doing at x sub 1, and the width of the rectangle is whatever delta x happens to be. So the height is f of x sub 1 times delta x, right? The second rectangle, if I use right-hand endpoints, on the right-hand side of the second rectangle is what the height is at x sub 2, right? So again, that green rectangle is kind of an underestimate. But on the right-hand side, we're using the x sub 2 partition. So we're doing the function value x sub 2 for the height, and then delta x for the width. All right? So likewise, we're going to do the function value at x sub 3 for the height of the third rectangle times delta x for the width. And then the last rectangle, we're going to do the function value at x sub 4, right, which is the same thing as b, but I'm going to use x sub 4, and then delta x for the width. So notice the subscripts kind of changed. For the left-hand endpoints, we're using x sub 0, x sub 1, x sub 2, and x sub 3. For the right-hand endpoints, we're going to do x sub 1, x sub 2, x sub 3, and x sub 4. right? So depending on whether we want to do the left or the right-hand side. So there is one more, okay? And it's called a midpoint estimate. And so let me put it here, the midpoint. Now the midpoint estimate, if we have 4 partitions, we're still going to find the area of 4 rectangles, right? So I still have height times width plus height times width 4 times here, okay? But the height we're going to find by calculating the midpoint, right? So what, I'm going to move up here, okay, to the graph. We call the midpoint, the first midpoint here, x of 1 star. Okay. The second midpoint we call x of 2 star. The third midpoint is x of 3 star. And the fourth midpoint is x of 4 star. All right. So if you notice, x of 1 star is halfway between x of 1 and x of 0. So you're going to do x of 1 minus x of 0 and divide it in half, right? So x of 2 star is halfway between x of 2 and x of 1. So we're going to do x of 2 minus x of 1 divided in half, right? And so on and so forth. So the height of this rectangles are going to be calculated by the height of these midpoints, right? So if I go up on the function and find the function value at x of 1 star, okay, and I'm going to mark it with this pink marker here. Now the height of the rectangle is going to be kind of halfway between our left endpoint and our right endpoint. So notice on the left here we got an underestimate, and on the right side we got an overestimate. So the midpoint here is probably the best approximation for the area we have so far. Okay, but the height is going to be the function value at x of 1 star. The width of this rectangle, right, is still delta x. We're still going from x of 0 to x of 1. Okay, so the width is still delta x. So we're going to get f of x of 1 star times delta x, right? And then let me go ahead and just fill this out. Okay, the second height, x of 2 star times delta x, x of 3 star times delta x, and then x of 4 star times delta x, all right? So we're just using those midpoints. So I'm going to go back up on the graph and continue to draw these rectangles in pink here. So the height at x of 2 star is about here. Okay, then the width goes all the way across. The height at x of 3 star is here, and the height at x of 4 star is about here. Okay, so we get different approximations, right? When the function is decreasing, going down like this, the left-hand endpoint is going to be an overestimate. The right-hand endpoint is going to be an underestimate. Okay, the green ones was an underestimate, and the midpoint is going to be a mix. Now, if the function was increasing, it would be the opposite, right? But we do have 3 ways, okay, of calculating the area using rectangles. So what I'd like to do, right, is I'd like to write these summations using sigma notation, all right? I kind of like to introduce you to how to write these within terms, okay, not just for terms, all right? So what we're going to do for in partitions, all right, let's go on the next page here. For in partitions. right? So I'm going to do a left-hand endpoint with in partition. So I'm going to do a subscript of n here. So we're going to do a summation, all right, a sigma sum. And that sum is going to start at I equals something, and it's going to go to something else. We're going to talk about how to figure that out, okay? Now, we're going to add up a bunch of lengths or heights times widths, right? So remember the height was the function value at x of 0, 1, 2, 3, or 4, right? So this is always going to be f of x sub I times delta x, okay? This is a bunch of heights times widths. So where do we start our left-hand endpoints, right? So remember when we were on the left hand, we started at x of 0, x of 1, x of 2, and x of 3, right? We started at the 0 subscript, and we ended at the 3rd subscript when we had 4 partitions. And so we're going to do the same here. If we have n partitions, we're going to start at 0, and we're going to stop at n minus 1. Okay. So note here, delta x still equals b minus a over n. Okay. So this is what this does, right? If I were to enumerate this sigma sum, okay, what we're going to do is I is called an index, and we're going to calculate this for each integer index, all right? So we're going to start at 0, and we're going to stop at n minus 1, all right? So our first term here is where I'm going to plug 0 in here. So we're going to do the function value at x of 0 times delta x plus, because it's a sigma sum. Now once I figure it out for x of 0, then I'm going to increase the index by 1 and plug it in. So now we're going to do I equals 1. So we're going to do the function value at x of 1 times delta x. And we're going to keep increasing our index, right, until we get to the last one. We're going to stop at n minus 1. So this is going to be f of x of n minus 1 times delta x, right? There's our left hand in partitions, right? Our right hand in partitions, right, is a sum. We're going to start at some I value. We're going to end at some value, okay, but it's always going to be the height, which is the function value at x of I, times the width, which is still delta x, right? So remember our right-hand endpoints. Where did our subscripts start at? For our right-hand endpoints, we used x of 1, 2, 3, and 4. So we didn't start at x of 0, right? We started with a subscript of 1, and we ended at 4. And this was when we had n partitions, right? So for our right-hand in partitions in our sigma sum, we're going to start at 1 this time, not at 0, and we're going to go to n, all right? So it starts 1 later and ends 1 later, but we're still going to have n rectangles or n partitions here. So we would do f of x of 1 times delta x. There's our first term of the summation. And then we're going to add that to the next term, which means we're going to increase that index by 1. And we're going to keep doing that until we get to our nth partition. All right? And so we'll do our nth rectangle times delta x. Now the midpoint, right? We are going to do our function at x of I star times delta x, all right? So what does I start with when we use the midpoints? Okay, the midpoints also was 1, 2, 3, and 4. So we're going to start the I at 1, and we're going to stop at n. So both the right hand and the midpoints go from 1 to n. The left hand starts at 0 and ends at n minus 1 to be on the left hand side of those rectangles. So this would look like f of x sub 1 star times delta x, and then we'd increase the index x sub 2 star times delta x, and we would continue doing that until we got to x sub n star times delta x. All right. So I would like to, start using the sigma sum notation. The appendix F that we're about to do is all about the sigma summations. Okay, so we're just kind of introducing you to those sigma summations just one section early. All right, so let's do an actual problem here, and let's go ahead and calculate the area under the curve for a particular function. Right? So we're going to let f of x equal x times x minus 3 squared. We want to calculate the area from 0 to 3. Using 3 partitions, right? Partitioned into 3 partitions. So most of the time they are going to make it a nice round number there, all right? But let's go ahead and calculate some items here. This is a cubic, correct? Right, and it has zeros of 0 and 3, and it's going to cross the x-axis at 0, and it's going to touch at 3. And so if I were to kind of sketch this, I don't know exactly how high it goes, but it's going to cross at 0, go up, come down, touch at 3, and then go back up, right? So we're looking at calculating the area from 0 to 3, and we're going to split this area into 3 partitions. So kind of like in thirds here, right? So A is 0 and B is 3, right? So what's the width, delta x, of our partitions? Well, it's 3 minus 0 divided by 3. So the width of all our partitions are 1, right? So if I were to kind of enumerate our x subscripts, okay, x sub 0 is 0. X sub 1 is 0 plus a delta x. 0 plus 1 is 1. X sub 2 is 0 plus 2 delta x's. So 0 plus 2 times 1 is 2. And x sub 3 is 0 plus 3 delta x's. So we're going to get 3 here, right? So notice that our third x sub 3 is equal to b, right? So this a value should always be our x sub 0, and the b value should always be our last partition there, okay? So what we want to do is we want to calculate the area from 0 to 3, partitioned into 3 partitions. So let's do left-hand endpoints first, all right? So the left-hand partition is the sum from I equals 0, and then the top is n minus 1, so basically that's 2, right? So the left-hand side of these rectangles, we're going to use 0, 1, and 2 basically, right? And we're going to do the function at x sub I times delta x, right? So if I were to kind of enumerate this, this is going to be the function. If I plug 0 in for I first, and then the function at x sub 1 times delta x, because after we're done with 0, then we're going to increase the index to 1, and then we're going to increase again to 2, but that's going to be our last one, right, because we need to stop at 2, All right. So we're doing these three rectangles. Notice one's our height and one's our width. So what is, okay, the function at x of 1, the function at x of 0 is really what is f of 0, right? Times delta x. X of 1 is just 1 times delta x, and x of 2 is just 2 times delta x. So I just want to calculate these function values here, right? And then it is nice because our delta x is just 1, right? So we're just going to multiply our function values times 1. Right, so the quickest way to do that is to go ahead and use your table feature in the calculator. So let's type the function n. And then go to the table, and I want 0, actually, let's just scroll, 0, 1, and 2. So f of 0 is 0, I should have known that. Delta x is 1. F of 1 is 4. Delta x is 1. And f of 2 is 2. And delta x is 1. Right? So we're basically that left-hand rectangle has a height of 0. Because on the left-hand side, the function's at 0. So it has no height. Right? And then on the left-hand side here, we were at 4. And then on this left-hand side, my graph is off, right? Because it should have been down at 2. But if I were to estimate the area, I would get an estimate of 6 units squared, right? So is the left hand an underestimate or an overestimate? A little bit of both, isn't it? Because it's increasing and decreasing, right? Let's go ahead and do our right hand endpoint, right? So r sub 3. This time, our summation is going to start at 1 and end at 3. Right? So we're going to do the function value at x of 1 times delta x. And then we're going to increase the index by 1 and do the function value at x of 2 times delta x, and we're still not to the end, so we're going to increase the index by 1 more and do x of 3 times delta x, right? Now f of x of 1 is, x of 1 is 1, right? So this is, let me go ahead and go up here. This is f of 1 times delta x. F of x of 2 is the function at 2 times delta x, and f of x of 3 is the function at 3 times delta x. And so let's calculate those numbers. All right, so the function value at 1 was 4 times delta x, which is 1. The function value at 2 was 2 times delta x. The function value at 3 is back at 0. So it looks like our right hand and our left hand estimate are the same, right? 6 units squared. Okay. So while I'm on this page, before I change and do the midpoint, okay, for 3 estimates, let's talk about what the midpoint is, right? Halfway between 0 and 1, basically. Halfway between x of 0 and x of 1. Right? So x of 1 star is going to be halfway in between here. Right? So between 0 and 1 is 0.5. What's x of 2 star? Right? It's halfway between 1 and 2 here. So we're looking at 1.5. What's x of 3 star? It's halfway between 2 and 3. So we're looking at 2.5. And we don't want to do x of 4 star, right? Because we only have 3 partitions. So we are looking at finding the function value at 0.5, 1.5, and 2.5, right? So let's go ahead. Let me switch papers here. This is a mess. All right. Let me get you the whole screen here, okay? So left hand with 3 partitions, right hand with 3 partitions, and then on the next page, I'm going to do the x of 1 stars. But notice on the midpoints, we start at 1 and end at n also, all right? So the midpoint with 3 is going to be the summation from I equals 1 to 3 of f of x of I star times delta x. So if I enumerate that, plug 1 in first, we're going to do f of x of 1 star times delta x. Increase the index by 1, f of x of 2 star times delta x. Increase the index by 1 again, x of 3 star times delta x, right? And then it is a good idea to know what those values are. So that's why I kind of calculated x of 1 star, x of 2 star, and x of 3 star in the previous page. So x of 1 star was 0.5 times delta x. X of 2 star was 1.5 times delta x. And then x of 3 star was 2.5 times delta x, right? So I need to calculate the function at each one of those. All right, so I need to go change my table real quick. So I can plug in 0.5, 1.5, and 2.5. So the function at 0.5 is 3.125. Delta x is still 1. The function value at 1.5 was 3.375 times 1. And the function value at 2.5 was 0.625 times 1. Right? So let's go ahead and add those up. I got 7.125, right, as our midpoint estimate, right? So it was a crude estimate because we only did 3 partitions. The way to get more accurate is to use more partitions, correct? Right? So let's go ahead and do one more. Okay, it is a bunch of number crunching, right? But it is important to be able to work through all this busy work, I guess. I don't know if it's busy work. It is just tedious number crunching. All right, new function. All right. E to the negative x. Find the area under the curve from 0 to 2. Using 4 partitions. All right, so everybody knows what e to the negative x looks like. Yes? All right, it's a negative exponential function like so. So we're going from 0 to 2. And we're going to split 0 to 2 into 4 partitions. All right, so x of 0 is 0. What's x of 1? Right? If we split 2 into 4 partitions, each width is going to be a half, right? 0.5, 1, 1.5, 2. So you kind of find delta x without realizing it. But the width of each partition is 2 minus 0 divided by 4, which is 1/2, right? 0.5. So x of 1, I'm going to use 0.5. X of 2 is 1. X of 3 is 1.5, and x of 4 is 2, right? Now while we're at it, let's go ahead and find the midpoints here, right? What's x sub 1 star, right? It's halfway between x sub 0 and x sub 1. So halfway between 0 and 5 is 0.25, right? What's x sub 2 star? Halfway between 0.5 and 1 is 0.75. X sub 3 star, halfway between 1 and 1.5 is 1.25. And x sub 4 star, halfway between 1.5 and 2 is 1.75. Right, so in all of our sigma sums, we know exactly what those x values are that we're calculating the area. Okay. So first, the left-hand estimate using 4. So remember our left-hand estimate, if we're using the left-hand side of that rectangle, we're going to use x sub 0 first. So we're going to go from 0, and we're going to do the left-hand side until we get to x sub 3. So this is going to be f of x sub I times delta x. Right. So I'm going to go ahead and plug the 0 in there. Right. So we got f of x sub 0 times delta x plus f of x sub 1 times delta x. Increase the index. X sub 3 times delta x, right? All right, I have what x sub 0, 1, 2, and 3 are over here, so I'm not going to rewrite it. Let's just go ahead and plug that into our function, okay? So I have a new function now, e to the negative x. And in that function, I want to plug x sub 0, x sub 1, x sub 2, and x sub 3. So x sub 0 is 0, x sub 1 is 0.5, x sub 2 is 1, x sub 3 is 1.5, right? And I want to write those down. So f of x sub 0 was 1. Now delta x this time is not 1, right? Delta x is 0.5. All right, f of x sub 0.5 was 0.6065 times delta x. The function at x sub 2 was 0.3679 times delta x. And the function value at x sub 3 is 0.2231 times delta x. All right. Now, if you wanted to, okay, you could factor out delta x. And in terms of calculating it, it might be a little bit easier, right? If I factored out delta x, then I'm just left with these function values being added, right? So if I took out a 0.5, I'm left with 1 plus 0.6065 plus 0.3679 plus 0.2231. So if you wanted to factor out that delta x to calculate it, it probably is a good idea. Right? So let's go ahead and calculate those. All right, so I got 1.09875. Right. All right, right-hand endpoints. We're going to do a summation from 1 to 4. F of x sub I times delta x. Right, so f of x sub 1 times delta x plus f of x sub 2 times delta x plus f of x sub 3 times delta x plus f of x sub 4 times delta x. All right, I am going to go ahead and factor out that delta x, which is 0.5, right? And then x of 1 is 0.5, so I'm going to do f of 0.5. X of 2 is 1, not 0.1, just 1. X of 3 is 1.5, and x of 4 is 2. Okay. All right, so I want to figure out those values. 0.5 was 0.6065. 1 was 0.3679. 1.5 was 0.2231. And 2 was 0.1353. Okay, so if I add all those up and multiply times 0.5, I got 0.6664. So the left-hand endpoints was more than the right-hand endpoints, but that's because it's a decreasing function, right? Our left-hand rectangles kind of go above it, right? And our right-hand rectangles are below. Right? And then our midpoints are going to be half above, half below. But let's go ahead and do that. So our midpoint summation, the midpoints go from 1 to n also. But we're using x sub I star. Can I shorthand and just go to this? We're going to do delta x times f of x of 1 star plus f of x of 2 star plus f of x of 3 star plus f of x of 4 star. So delta x is 0.5. X of 1 star, we calculated already. This is the function value at 0.25. X of 2 star is 0.75. X of 3 star was 1.25. And then x of 4 star was 1.75. So I kind of have some new function values to plug in there. So let's do that. .25, 0.75, 1.25, 1.75. All right, 0.85575. All right. It's a little tedious, but hopefully you understand the mechanics. And then if you don't understand left-hand versus right-hand endpoints, kind of just look back at the first of the video. And of course, I am more than happy to help you. Just send me a message, and we'll set up a Zoom meeting. All right, take care, guys.